Stoichiometry. Isn't that a great word? Stoichiometry. It just makes you want to say it. Stoichiometry, stoichiometry. Stoichiometry is a fancy word that just means how many grams do I expect to get out of this reaction. If I start with so many grams of a reactant, how many grams of product do I expect to get? That's what it's all about. So let's write down an equation. We need a balanced equation to start with. And I'm going to use one that we used when we balanced our equations on the other page. So, oops, that's a 6, supposed to be a 6. 6 lithium nitrate. Doesn't look much like a 6, but I guess it'll do. And aluminum carbonate. So, here we go. We have 2 aluminum nitrates, 3 lithium carbonates, 6 lithium nitrates, and 1 aluminum carbonate in this equation. The coefficients here tell us the ratios. And that is a good thing we need to know. If I start with 2 aluminum nitrates, I should expect to get 1 aluminum carbonate. If I start with 3 lithium carbonates, I expect to get 1 aluminum carbonate. So we can use these. Now, these ratios are of the molecules, atoms, formula units, whatever. So that's what it's good for. But since there's the same number of things in every mole, there's always Avogadro's number, we can also use these ratios for moles. And that's what we're going to do for the most part. We're going to use the ratios for moles. So we could say that 2 moles of aluminum nitrate, if we start our reaction with 2 moles of aluminum nitrate, I should expect to get 6 moles of lithium nitrate out of it. And I should expect to get 1 mole of aluminum carbonate out of it. And I can set these guys up in conversion factors. So if I'm starting actually with grams, normally we can't just look at something and say, ha, that's 2 moles. I have to start with grams because grams, I live in the macroscopic world. I don't live in the microscopic world where I can just look at the atoms and count them one by one. So I have to find out how much I've got by weighing it on a balance. So I've got 16 grams of aluminum nitrate, and I want to know now how many grams of aluminum carbonate I should expect to get out of this equation. That will be my theoretical yield. So I'm asking about the theoretical yield. Theoretical yield, what I should get if conditions were perfect, if everything were going exactly the way it ought to, and I got 100% of it doing what it's going to do. Never is true in real life, but we can at least figure out what we ought to get. All right, so now, the balanced equation, the coefficients in the balanced equation talk about moles. But in the real world, in the lab, I can weigh out grams. I can't weigh out moles. So the first thing I'm going to do is I'm going to change this into moles so that I can look at the ratio from the balanced equation. The balanced equation only talks to me in moles, and so I have to translate my stuff into that language. I have to go into the mole language so that I can talk to the balanced equation. Now, the balanced equation is very useful in telling me that I have 2 moles of aluminum nitrate to 1 mole of aluminum carbonate. That's excellent. Going on, now, moles of aluminum carbonate, it's great that we know that, but that's really not what we were after. What we were after was grams. And so now I can go back and change my aluminum carbonate back into grams. And how do I do that? To go from grams to moles, we use the molar mass because the molar mass is grams per mole. And so I have to look that up on the periodic table, add up all those values, and I can just substitute those in there, and everything is peachy, and I can get my answer then in grams of aluminum carbonate. by just running it through the calculator. Notice that if I just used the ratios of the molar masses, I wouldn't get there because it's a 2-to-1 ratio in the balanced equation. So I always have to take the grams that I have. The idea here is grams of substance A, whatever we've got. We're going to change that to moles of A, then change that to moles of B, change that to grams of B. That's our plan. Each one of these arrows, each one of these steps, this is step 1, step 2, step 3, each one of those is a conversion factor. So I end up with, I write my conversion factors like parentheses, so I end up with 1, 2, 3 parentheses, and each step gets me closer to my goal of knowing how many grams of the product I should expect to get.